Welcome to this new episode of Talk to the Expert, where we will explore how industrial companies can deploy computer vision models at the edge. My name is Miren, Head of Marketing at Barbara, and I will be conducting this webinar together with Kike Ramírez, our solution architect. Edge computer vision is rapidly becoming one of the most transformative areas in edge AI, driven by the need for real-time insights, reduced latency, and lower cloud cost. Key uses where edge computer vision delivers high impact include visual inspection and quality control in both process and discrete manufacturing, logistics and inventory monitoring across warehouses and supply chains, worker safety and compliance in sectors like construction, oil and gas, and mining, as well as predictive maintenance via visual cues for utilities, transport, and heavy industry. To guide us through this journey, Kike will showcase a generic deployment of a computer vision model using Ultralytics YOLO version 11. So Kike, can you tell us what we are about to see?
Sure, Miriam. Nice to be with you today. And yes, what we're going to cover today is just a generic deployment of a generic computer vision architecture. Okay, we have seen before one of the most used. This is one of the most used technology in industries in the last time for this use case you mentioned before, like visual inspection or worker safety or predictive maintenance, these kind of things. Okay, so today what we are going to show is how to deploy a generic solution. In this case, we will use the applications that are available in our marketplace to create this solution, and we will apply an AI model developed by Ultralytics, and it is also available in our marketplace. So in this case, we will be searching for generic pattern, generic objects in a video stream we will use. Okay, so I will share my screen and I will start. Let me check it. We have here, fantastic. So now let's start deploying this architecture we are going to use. So let me present first the architecture we are going to deploy today. Okay, we will be using just one edge node. This rectangle we have here is the edge node. We have deployed it in the field, and we will access this device using Barbara panel to manage the device and to install this architecture using different applications. Okay, so what will be the core of the architecture we are going to use? This MQTT broker, it will act as the communication backbone of everything. Okay, so all the data will go through this item. Okay, so this is the first thing we will install in the edge node, the broker. Then we will add an application that is called a video reader. It is an application that can connect to any external camera or any external video source. And using different protocol, you can get the images from the camera and you can publish them in the MQTT broker. That's perfect for what we need. Okay, so using this application here, we will get frame by frame the video in the camera, and it will be published in the broker. So in the third step, what we have is this solution, a video player solution, because we need to visualize what is happening. Okay, so we need a player to see how is the video we are working with, how are the detection going, and all this kind of thing. So in order to do that, we will deploy this application. This is an application that just connects to the broker and reads a video stream, and then you can open a browser tab to connect to this application and to visualize the video in this in the browser, right? We will do that also. Then the fourth step, and the more important, okay, we need to apply some AI model to this video stream. Okay, as we mentioned before, imagine we are trying to find some leakage in any pipe or whatever. So we need an AI model that detect this kind of thing. In this case, we are detecting just an generic object. We will use this Ultralytics YOLO model, and we will connect the model to the broker. Okay, and then we will receive the video stream from the camera. It's being published here. We will analyze this video stream, and we will generate two more outputs. Okay. In fact, we generate three, but we are going to use only two. We will generate a new video output containing the detection on the original video, okay? we will be able to visualize it here also in the player. And then we will have also, obviously, some telemetry data about the detection. Okay, our model is continuously generating data about how many objects have detected in every frame, where the position, the sizes, etc. So we are going to catch this telemetry that will be published again here. And this step, what we will do is storing the information in a time series database. We will deploy an Influx database. We will ingest the information using this little piece here. This is an ingester to move the data from the broker to the InfluxDB. And finally, we will have a Grafana, which is a dashboard that will help me to visualize all the data of the process. Okay, so this is what we are going to deploy. We are going to deploy this application. We are going to use this is panel. Okay, we have different edge node here that can be used to deploy this use case. We can see where are they located also. So we will just select one machine I have prepared for this talk to the expert session. And I will do this one. This is the one I want to use because it is it has a GPU. Okay, so it is very convenient for this case where we are going to run a quite heavy AI model in the edge. So we will use this one with GPU. And here we can see some of the values, some of the property of the edge node in the node information area. We can see, for example, the networking card with all the information about the network of this AI, of this edge node. So I will use this IPN, this VPN, sorry, we see here. This is a VPN that is enabled for all of the edge nodes that are being handled by panel. I can enable or disable it, but this is the IP of my edge node, and I will use this IP to connect to the service later. Okay, so I will start directly. Okay, Miriam, I will just start deploying the application. In order to do that, I go to this application and models area. Okay, and I can see here that I have no application installed in this edge node. Okay, so how can I do upload application to this edge node? Well, I will go directly to my marketplace. Okay, I can see here all the applications that are available in the marketplace. And in this case, for example, I am going to open the artificial intelligence section because here I can find some of the application I'm going to use in this use case. Okay, for example, I can find here the video reader. That is the application that helped me to connect to different kind of cameras and protocols, okay, and publish the information there. So in order to use this application, the only thing I need to is to press this button to add the application to the library. But in this case, it is already in my library. That is why I cannot push this button, okay? But then once you have moved your application to your library, you just need to go back and you will find the application in your library and you will be able to deploy it in the edge node. So let's start directly. I will just deploy the MQTT broker application, right? So I can use the technical notes that I have available here in this wizard to configure everything about any application we have published in the marketplace. So all information is available. It's very easy to configure. We always provide default values, etc. So when we have configured the basic parameters of the application, the port where it's going to be serving, the volume is going to use, etc., we send the application and we will see that we have now a new broker here running in the edge node. Okay, this is the communication backbone. Let's then deploy also the video reader application to get the video stream from the camera. Okay, and I have here the video reader application. In this case, I will configure it to connect to the broker. Okay, that is something that must connect. Okay, but also I need to indicate here the source of my video. Okay, this is the name of the video stream I am going to generate in the broker. This will be called video reader 01, but it will try to connect to the camera that is being streamed in this URL. So that is the only thing we do. We send the application and we will see we have the video reader. I didn't show you, but we have the logs of every application mirrored here. So it is very easy to go to video reader and check what is happening. We are starting to process the video. So everything seems to be okay. And now I will add the video player. Okay. So in this case, again, what I'm going to do is connecting to the broker to receive the information about the video stream and indicate the port where this tool is going to be published, the 5080. And then I will just indicate here that the name of the video stream I want to visualize is called Video Reader 01. Okay, that was the name of the video generated by the reader. Okay, so I send it. And now I will be able to go to node info, copy my IP, and now I will be able to access this player to visualize the original video, okay? I can check it was available in the port 5080. So now, just we need to open a new tab using this IP and the port 5080. And voila, this is the original video that we will use, okay? So we have now prepared these three applications, the simulator, the blocker, and the player. Let's just install the inference server very quickly, and let's start to work with this AI model. So in order to do that, I will just collapse this part, and then I will add a new application. It is called Ultralytics, and I have several flavors for that. I will use this one for GPU, okay? So I will configure the AI model to connect to the broker and start reading, okay? And also I will indicate here that the original name of the original video name is this one, Video Reader 01. This is the video I'm going to analyze using the AI model. This is the model I am going to use to detect the pattern, the Kike YOLO View 11. And then this will be the name of the video output. Okay, I'm going to generate a new video output with this name. And also this is the name of the telemetry we're going to save in the database. So I send this application. Again, we will have a new card here indicating the status. I can check here, it has started, okay. We have here the classes we have for this model. We have all the information here in the log. So now, if I go back to my player, I won't see anything new because I'm still visualizing the original video, okay? So what I need to do to visualize the new output video with the detection is going to this application config. And here indicating that the video I want to visualize now, I want to play now, it's not this one, but this one. Okay, this is the new name for the new output. So I send this and I go back here, and in some second, as soon as it is applied, I will start seeing some detections in the video. Okay, let's see. Here we have it. Okay, so now as you can see, Miren, we have the final video, the new output video using this detection. Okay, now check how easy it is to set up the flow. Okay, and connect the AI model and start predicting things or detecting patterns or whatever. So the core is it. Okay, so what is the last step we are going to use? Normally, all these AI model, obviously, they generate numeric information, okay, and data in JSON format, this kind of thing, to check all the all the detection that have happened in every frame for which characteristic, etc. So this is also very common to take this data and store it locally in the edge node, so you can review them later, you can check trends, you can analyze them. Okay, so that is what we are going to do. And we are going to install the InfluxDB database, okay, and the ingestor. Okay, so we will do that in the next step. So I will collapse everything again, and I will add just an Influx database to store all the information. Okay, I will just detect it using the default values, and then I can enter here, okay, and visualize my database. How can I do that? Again, I just need to know the port where it's going to be published, 8086. So now I can check again my IP is here, okay, and with this IP and the port 8086, I will be able to enter in my InfluxDB database, okay? So let's review. I have nothing in my database, okay? I can go directly here and I can see that I have no data to explore in my database. This is empty. So now what is the next step? Obviously, we need this ingester, which was the application that was moving the information from the broker to the database. So I will just select it. InfluxDB ingester. This one. Okay, I will use the last version. So hold on, because I made a mistake. I'm going to remove the application because I didn't configure it, so it was not going to work. I have here the application, and again, now I'm going to configure it to connect to the broker, and now I am going to use here a different configuration, and you can store template for your configuration. So that is what we are going to do now, okay? I'm going to search for this configuration here. We have store, we will load it. And here what we are saying is basically you need to search for this measurement in the broker for this name, and then you publish it in bucket in this bucket in the InfluxDB using this name. Okay, so what is we're going to do? I will send this application. We will have the ingester running, and I can see in the logs that it is already writing. Okay, it is already writing in the database. We are going to check it. Okay, we can go back here, and we can see. We can see. Here we are. That now we have a YOLO11 telemetry data here. So I can just make a query and check that I have just started to receive the information from the AI model, right? So now last step we are going to finish. Okay, the last step is just deploying this Grafana here, the application that allowed me to have a dashboard visualizing all the data together. So I will do that. I will just add the Grafana application. Okay, with the last version. Okay, so now the only thing I need to do is adding here a predefined dashboard that I have prepared also in this template. So I will select it, I will load it, and that's all. I will send the application. So now I will be able, as soon as this application starts, I will be able to open a new tab, and using the IP and the port 13,000, which is where Grafana is, I will be able to enter in the dashboard and check all the data that I am receiving from this AI model, okay, with the number of cars, person, etc. So again, this is a way of creating this kind of architecture that allow you to receive information from a video source, okay, publish it in a central hub, communication hub, and then you have the way to visualize it, the way to analyze it, and the way to store all the data locally and have your own dashboard to visualize the process. Okay. So, well, more or less, it's all about this generic deployment. Meaning, I don't know, you have any question about it?
Yes. So let's start with a practical question. If a company wants to use these computer vision models but doesn't have the in-house expertise to develop them from scratch, what are their options?
Well, the option in case they don't know how to train their own AI model. This is something that usually happens. Okay, we can provide a solution for that, an AI model correctly trained for that using our partner ecosystem. Okay, we have partnered with several companies that they can provide solution about AI model, and in fact, some of these solutions that our partner provide are also available in the marketplace. Okay, so we can go here to the marketplace. We have a complete category called artificial intelligence, where you will find plenty of solutions, not only AI models, okay, because we can also offer tools like MLflow to work with the AI model in the edge node. We have video solution, the one that we have been using in the demo, and LLM, etc. So there are plenty of possibilities here in the marketplace. In case they need something more concrete, more detailed, we can contact directly our partner.
Okay, how does Barbara help scale this solution? Because this is one of the typical questions of our customers.
Yes, and in fact, this is a very good question, because normally this kind of architecture is not the thing that our user need. They need this, but scale a lot. Okay, so we have different ways of scaling, and in fact, Barbara panel is made for scaling. Okay, that is our main purpose. But the first way you have for scaling things is scaling the application, scaling the video source that you are managing with one solution like this one, for example, here. That is why we have also this MQTT broker at the center architecture that allow me to decouple everything. So I can just connect more cameras here, okay, to be able to process them here in this part. Or even I can add more AI models in parallel and connect them to a broker, okay? And so this way I can analyze more things, or I can analyze more video sources in parallel. Obviously, you need enough powerful hardware to do that, okay? So in case your hardware is not very powerful, you will not be able to scale a lot this way. But in that case, you can always do what Barbara do well, that is using several edge nodes, replicating this use case in other locations. Imagine you have deployed this solution in one plant and it was working fine, and now you want to replicate this already tested solution in 30 or 100 more plants. Okay, how we will do that in Barbara? It is very simple. We will need to command the nodes in parallel. Okay, so we have been working with just one edge node, commanding just one edge node, but I can always go to my edge nodes, select all the edge nodes I want, okay, and then command them in parallel. So I can replicate the same use case in 100 edge nodes in parallel if necessary. So this is the other way you have for scaling. So you won't have a problem to scale the use case. It is very quick to do, and it is very good for debugging and finding problems.
Super interesting. Thank you. Now let's talk about reliability, because in a production environment, how do we ensure that the system runs 24/7? And how do we guarantee high availability of the edge devices?
Well, basically, the main feature we have for high availability has just been moved to production is the cluster mode. Okay, so we can see here that apart from this edge node we also can find clusters. Okay, so this is a way of working. Another way of working in Barbara, when you create a cluster with several edge nodes in parallel connected to the cluster. Okay, so in case some of the edge nodes lose the communication or have some hardware problem or whatever, you will still have some other edge node that will take the task that this one was doing. So the service will be running 24/7. Okay. Not only the application are clusterized, also the volumes, so the data will be also available for all of them in case you're running databases and this kind of thing. So that is the best way of assuring that your services that you have deployed in any instance, in any environment, will be available 24/7. Okay.
Thank you very much, Kike, for this session, and hope the audience found it interesting, and we invite you for our next Talk to the Expert that we will have it very, very shortly. Thank you very much.
Bye-bye.
Bye-bye.